Hello, thank you for joining. I am Krystal Curry. Welcome to Curry Girl Tech Talk. Today we are continuing our Web3 series. I'm talking tech today with Beddhu Murali. Today, Beddhu and I are going to give you all the scoop about blockchain technology. We're going to talk about smart contracts, how to implement smart contracts. We'll talk about what's new and what's happening behind the scenes with all of the technology that is fueling Web3. Welcome to the show, Beddhu. Let's tell the audience a little bit more about you.
All right. So I have a PhD in aerospace engineering, and I teach computer science, and I'm a small business owner. And whatever computer science I know is self-taught, and I worked a number of years in different research capacities, and I picked enough about computer science that I started teaching it. And whatever knowledge I have about blockchain is through teaching a course on blockchains and applications for the past 3 years. So hopefully I can clarify some of these things.
Thank you for being here. So we know that blockchain technology is complicated to a lot of people. Let's start with just the basic fundamentals of what blockchain technology is.
All right. So you probably have interacted with websites, right? So you buy airplane tickets or you order food, right? So there are websites where you can do many things. You can go to google.com and search for stuff. Those websites are typically owned by some person or a company, and they control all the activities that goes on in that website, right? So they run that website, they have their code, and they don't have to show what's in their code. And you trust them with your data and you interact with the website. You can think of a blockchain as a website. It's something available online and you're interacting with it. But the difference is all your interactions with the blockchain is recorded and it is publicly available. However, there is some element of privacy in the sense that what is publicly visible is your string of numbers called your public address or public key. So that's the part that is visible, and who you are is not that visible unless you reveal yourself. So the other thing is that in blockchain, it is called trustless because there is no intermediary third party that is holding all the software. The software is public. So if I put some code on the blockchain, anybody in the world can read that code. They cannot modify that code, but they can read what my code does. People interact with the blockchain just like they interact with any other web service, right? So you use buttons to click things, or you fill in some form and you send data. So from a user point of view, it's just a website. Right, you can treat it like a website. Only difference is whatever you do, it is visible to other people. So they do not know who you are, but they can track your activities. So if you send money to another party whose address you know, the blockchain record it's like when you send a mail. Right? So the postal service knows who sent mail to whom because you put the from address and to address. The content of the mail may be private to you. Similarly, there are informations that get recorded on the blockchain. Whatever you perform on the blockchain is called a transaction, and the transactions get recorded in addition to who initiated the transaction, who is the beneficiary of the transaction. So there are some details that are recorded on the blockchain. It is visible for the public. So anybody in the world can investigate. And there are websites that allow that, right? So if you can run your own node, you can interact with that node, which will interact with blockchain. Or there are websites, they run the nodes for you and provide a form that you can fill out and get the information you want.
I was thinking about the dichotomy between privacy and security. I've heard a school of thought that they are mutually exclusive, that you can't have privacy and security, because if you have privacy, then it's not as secure as it could be. For instance, like we have with blockchain, the transactions are all public, as you just explained. Well, if it's all public, then it's not truly private in some ways, but we want it to be public because that is what makes it more secure. Do you agree that you acquiesce a certain part of your privacy just to have security? Or is that metadata that's recorded in that transaction? It's nothing about yourself, but all about only the transaction itself. How do you have both privacy and security?
Okay, so we have to define what we mean by privacy and what we mean by security before we can discuss, do we give up one or the other, right? Is there a trade-off here? Okay. When we say blockchain is public, whatever transactions that occur, let's say the examples of money transfer, right? So in order for us to verify, so previously you might have heard this thing called trust but verify, right? In blockchain, trust is through verification. Before anything goes on the blockchain, it gets thoroughly vetted and verified. So if you are sending money, you cannot send money you don't have, right? So for example, if you go to a bank, you deposit $100 and you go to your friend A, you give them $100 check, and friend B, you give them $100 check. And one of them goes to the bank first, gets the money. The second one goes to the bank, it bounces, right? So that means that the bank is serving as an agent that prevents the so-called double spend problem. So we are trusting the system, right, the bank, to manage that for us. So in blockchain, there is no bank, right? So blockchain is just a piece of software running on the cloud. So that software has to maintain that you have money before you can send it to somebody else. Right? So that is why the transactions get recorded. The sender has an address, the receiver has an address, and who those parties are in terms of humans, we don't know. Okay, so there are cases where people have hacked blockchain code. They siphoned money off, but
I did read about that.
Right.
In my research, I read about that. I read where somebody had hacked it, and what he did is he was able to do that same method that you talked about, where the bank acts as the intermediary and they prevent you from being able to do those multiple transactions in the case where you have the $100, but the first person that gets to the bank gets it first. Well, he was able to compromise the code and use that same cycle of money, that same $100 multiple times, and nobody would have ever caught it. He exploited the code where they kept it digitally.
He was not clever. It was a bug in the creator of the software, right? So the software creator made some assumptions and did not check their code before they put it on the blockchain. So anybody can read code on a blockchain. Clever people look for mistakes in the code that they can exploit for their benefit. They're not modifying the code. They are using the code as it is written.
I see what you're saying.
Right? So they are doing that for their benefit. Personally, I'm not sure that is illegal. It may be unethical, right? It's not illegal. You cannot catch those people and put them in jail because they used what is there, right? So you released it publicly. You didn't verify it. You have $1 million sitting in your online account, right? Smart contract account. And it is vulnerable, and they exploited a mistake in your code and they took the money out. The point is, we don't know who took it. We know their public address, the address that is visible, but we do not know the identity of the individual. So you have a phone number that can be your number associated with you. Similarly, when you go and interact with the blockchain, you create an identity for yourself. So you create that number. So that number is unique to you, but it's not traceable by somebody else to you. So is that private? Or is that public, right? There is both are there. The public part is so that it can be verified. So before you send money to somebody else, the system has to verify you have that. And that system of code is also public so that people can read that code and trust that code. And if there are mistakes in such code, it is going to be expensive to the ones who put that code on that. But then it is also a learning opportunity for all the other software writers. We need to avoid that, right? So if Google makes a mistake in their code internally, nobody else knows about it unless Google says about it. So that's the advantage you have when you have things on the blockchain.
Hash 256 is the code protocol that is used by blockchain, and that's the securest way to do things. Can you tell us a little bit about hash 256?
So you probably know Google Translate. So you put in sentence in English, it gives you sentence in French or some other language. Similarly, you can think of the hash as some kind of translator. Whatever amount of text you give, whether it is 2 sentences or an encyclopedia, regardless of the amount of input, the output is always going to be 256 bits. One bit is a 0 or a 1, so you have 256 bits. That's what you get out of this translator. And those 256 bits are unique to that input. So if you make a slightest change to the input, the output will be drastically different. So in other words, given the output, you cannot regenerate the input. So in translator, if I give a French sentence, you can go back to the English. In this hash 256, if you give me the hash, I cannot give you the original text. So in that sense, it is secure. Each input produces a unique output. Any slight change in the input will be drastically different. In other words, you cannot predict what the output would be for a smallest change. Even if you change 1 bit in an encyclopedia, it's going to be drastically different. So when you use that system, it becomes tamper-proof, right? And all your transactions are recorded using hash 256. There is something called KAK 256. That's the name of the algorithm. In other words, how can you change, right? So you go and change the history. So, for example, you want to send somebody $100 and then erase that, right? If you try to do that, on a blockchain, you will break the hash. The hashes won't agree with the history. So nodes that are running the blockchain will quickly reject your attempt. So that's how the hash helps maintain the trustworthiness of blockchain.
Awesome explanation. When you were talking about the code, I started to think about Solidity. That's one of the programming languages that is used to do smart contracts. And there's certain level, of course, of technology knowledge that you have to know in order to be able to program in Solidity. How are people operating in the Web3 environment with these smart contracts? Is it mostly just companies that already have a team of developers that know Solidity? But like if you're a business owner and you don't have a background in programming and you want to utilize a smart contract in the Web3 world, how would you go about doing that? And you just have to trust that their code is going to execute correctly on the blockchain?
Okay, so when you use your iPhone or your Apple device, do you need to know Swift or Objective-C or any of the Apple's programming languages? You don't. right? Same way, in order to use the technology, you don't need to know the Solidity programming language. There are blockchains or blockchain environments written in other programming languages also, like OCaml. So in order to use that, you don't need to know. Similar, if you are, say, a restaurant operator or owner, and you want to make an online menu for your restaurant, you find somebody who knows how to do it. The same way, if you want to offer something on a blockchain, for example, you want to sell something accepting crypto, then you find somebody who knows how to do it and pay them. You find somebody who knows it and you get things done.
Hi, everybody. Happy Thanksgiving. I am Krystal Curry from Curry Girl Tech Talk. I am just full of gratitude for each and every one of you for listening and for being a part of this journey. I hope that you have a wonderful holiday with your family and friends. Happy Thanksgiving. And businesses can use this with smart contracts and trust it's going to operate when certain preset conditions are met. Is it tested like the individual parties, or is it just put on the blockchain that if the requirement of the contract for me to purchase a house that I put down $1,000 earnest money, if the smart contract executes once it grabs that $1,000 and then it goes into the other components of the contract, somebody, is supposed to sign over a deed or something to me at some point in this smart contract. Those components are just are written in the code, and there's nobody that's intervening in the transaction. And once it's all done, the transaction is complete on the blockchain, and it's recorded and it's public. Is it as simple as that and as smooth as that?
It can be. It depends. So once you put the code on the blockchain, it is publicly visible. Anybody in the world can read the code. They cannot modify it. We got to get into what's called decentralized organizations, DAOs, and so that there are ways you can programmatically modify things on the blockchain. There are things like diamond contracts that enable you to use the same address and modify code. There are things you can do, but in general, once you put something on the blockchain, you cannot change it. You can do some of these things you described in the Web2 sense. You go to some bank's website and they, get all the details from you and so forth. We can do similar things on a blockchain, but that code needs to be written. Right, somebody has to write it, and the testing of code that you put on blockchain is more involved. So once you put it on the blockchain, you can put a different code, but you cannot edit your previous code. Okay, so as a software writer, you want to make sure whatever you put absolutely works. There are all kinds of tools available to test things, right? So there are tools available where you can run your own private blockchain on your laptop, which means only your contract is going to be on that. So there is things called fuzz testing, invariant testing, A/B testing. There are all kinds of testing that you need to do in order for you to make sure that the contract you put is as foolproof as humanly possible. Is there a way to back out the code? Like say you put a smart contract in there and then you realize, some mistake, or error in the code. Is there a mechanism to back that out and replace it with a new set of code? I know you said that once it's on the blockchain, there's no way to edit it or modify it, but is there a way to take it back out completely and reload a new version of code? No. Whatever you put on the blockchain stays on the blockchain forever. If you put something on Ethereum, it will be there. So you make sure before you put on Ethereum, everything works. We are all humans. There are so many times you send an email and then realize, I don't want to do that. Things happen. Okay, if you follow the traditional setup, there are ways to shut it down, right? So prevent further transactions from occurring on the blockchain, but your code will be there. So like I mentioned earlier, there is a mechanism called diamond contracts. It uses the analogy of diamonds and facets. Those contracts it is possible to say, replace one contract with a different one, but whatever original one you put on the blockchain will be on the blockchain. You might have known something called Uniswap, right? Uniswap version 2 is on blockchain. Uniswap version 3 is also on blockchain. And they are written such that once it's on the blockchain, it cannot be removed. So there are people who are still using Uniswap 2. They don't want to switch to Uniswap 3. Even the company Uniswap has no way of stopping them. So that is the beauty of block. That's the advantage of blockchain. If you like something, it's there. Nobody can take it away.
What other types of use cases have you seen in a Web3 world with smart contracts and blockchain technology? Because we tend to, I know for me, I mostly thought about it in terms of financial transactions because fintech highlighted this technology more than anybody else. And then we think about cryptocurrencies and things like that. But any other use cases that you can share with us?
Yeah, I think currently the leading application domain for blockchain is financial transactions from private individuals to companies to industries to even governments are trying to conduct transactions using blockchain. They are trying to negotiate exchange rates through blockchain. So it is interesting. A lot of interesting work is going on using blockchain. And there are efforts using blockchain to enable better e commerce, to sort of level the playing field or to make small businesses be as competitive as large businesses, or small businesses not be beholden to large business. So there are efforts, not necessarily in the US, but around the world, that is happening. Even though the blockchain technology originated here in the US, let's say Satoshi is a US citizen. So let's assume that. And so it started here. There are other parts of the world that are running with the blockchain technology that I think more beneficial to society at large. So it would be nice if we can adopt some of those developments, bring it to the US, and we could actually provide better services to society, the US population. Lots of exciting things are happening in blockchain, but then people also have made mistakes, right? They have taken missteps. Apart from coding errors, deliberate misleading the public kind of efforts, right? Sam Fried Bankman, I call him Sam Fried Fraud Bankman. Anyway, he's one example of what you shouldn't do on a blockchain. So it has brought some bad name and sort of tarnished the reputation. But I believe there are, extremely noble-minded people that are working in the blockchain space, and I believe we will have more impact on society as time goes by. And if they're just getting started out with Web3 and they just want to get into the blockchain, they have to have one of the new browsers in order to connect to Web3 type of applications or to use blockchain technology. You can use any browser you want. Okay. Yeah, from a user point of view, there will be no difference between a website, like in Web 2 website and a Web 3 website. The user interface will be the same. In the other side, if you are in a Web 2 world, the back end, so the cloud where you are connecting to, is controlled by some entity. On the other hand, in the blockchain world, the back end is the blockchain. So all your data resides in the blockchain. Of course, there are layer 2 technologies where you can keep some of the data off the blockchain, but you still record all your transactions on the blockchain. So the only part where you need some browser add-on, right, if you are a end user or not well versed with programming, is a way to protect your private key, right? So there is something called private key. It's sort of like your password, but the major difference is if you forget your password, you can go somewhere and reset. On the other hand, if you lose your private key, then you lost everything. You have to protect that private key, like is an important asset.
It's actually unrecoverable. There's no way you can get your
Exactly.
private key back.
Exactly. If you lose it,
Goodness.
losing means there are a couple of ways you can lose, right? If somebody gets hold of your private key, then you may remember your private key, you may have it in your possession, but your money is gone. Right, so then having the private key doesn't help. Right? That is one way to define loss. Another way is, let's say you had it only on your computer and your hard drive crashed. There is no way you can recover the data from the hard drive. Then you lost your key, which means you lost all your assets also. Yeah, there are stories on the internet floating around where people have lost their keys and cannot access, millions of dollars because they don't have the key.
And what happens in that case where somebody's lost their keys and that money that's just there?
It's there on the internet. It's as if like it evaporated from your life. It's on the internet. You cannot access it, and nobody can access it.
That's scary. So don't lose your private keys, guys.
Yes, you have to protect it like like your life.
Now, like if say they lost their private keys and they had done nothing on the blockchain yet, they had these private keys generated and they haven't used them. If they wanted to start back over again, they can get a new set.
Yeah,
Okay,
yeah. If you haven't not used your private, you can actually have hundreds of private keys. Right, you just have to manage them, right? Which key you are using where, and there is something called ephemeral wallets, right? And so you can use it once, burner wallets, right? So you just use it once and don't use it again. For example, you send transactions. So your account is nothing but your account number, similar to what you have in your bank, right? Your public address will be your account number. It is also your identity. You can transfer money from one public address to another public address that you control yourself. In that way, you can have some way of avoiding being tracked. Some of these things you can do if you know how to write programs. There is something called MetaMask, so that is very popular. It's a browser add-on. So any browser you can add that on, and that is one way to securely store your private key. And people also make devices where you can, store your private key. People use external storage like a thumb drive or some other device to store the private key. So the private key is extremely important. You cannot afford to lose it unless you can afford to lose your money.
Now, I want to talk about mining coins when we talk about currency. How does that work with mining? There's a specific device that is used to actually do this mining process. And from what I understand, and that it's really sort of a labor intensive and expensive sort of process.
You are, I believe, talking about Bitcoin mining.
Bitcoin mining.
Right. Bitcoin mining. So Bitcoin uses something called proof of work. A miner's job is to assemble valid transactions. So somebody has to validate them. So you got to get a set of valid transactions and put them in what's called a block. So in generating the block, they use these cryptographic hashing algorithms. So the miner has to generate a block, generate a hash which has so many leading zeros. The hash is going to be 256, but you have to generate, let's say, 192 leading zeros followed by whatever. Generating a hash with that many leading zeros requires a lot of computational effort. So there are companies, actually there is one company that has sort of cornered the market on that, because this hashing algorithm does one specific thing. So they designed and made a device just to do that. So that is one of the unexpected, unintended drawbacks of Bitcoin.
Mm-hmm. Mm-hmm.
So the mining itself is, if you build a block, then you get to generate Bitcoin out of thin air. If your block is accepted, then you get a reward for putting that effort to create that block. And that block, that's the way Bitcoin gets generated. And there is only going to be a limited supply of Bitcoin ever. So that is one of the attractive features of Bitcoin from an investor's point of view.
Right, because the miners themselves earn the actual coin, the Bitcoins, for doing the mining process.
Correct.
And that is their incentive for doing it.
Correct.
Which some of them, I suppose, can get quite wealthy doing that process.
Yes. It depends on the price of Bitcoin in terms of dollars.
Any closing thoughts about the overall value proposition of Web3?
Blockchain is a extremely useful technology from my point of view, and it is still being developed, right? So there are many application domains where we can use blockchain. Blockchain has the potential to benefit a lot of people, and blockchain brings in a level of trust, right? Even though it's called trustless, to many entities around the world, right? So we can do global transactions using blockchain. My personal aspiration, or what I would like to see, is blockchain and artificial intelligence getting connected. When that happens, I believe the world would be the world, not necessarily humans alone, can benefit a lot by that unification or integration of artificial intelligence on blockchain. One last question.
We know that there's a lot of pressure that technology is putting on the electrical grid. What insights do you want to add there?
True. There's a lot of, not only blockchain and AI. So, electrification of vehicles, right? That also adds additional demand on the grid. The projections of what we need just for AI is mind-boggling, right? People talk about from 8% of the national energy production to 30% of energy production. Those numbers are huge. And we are interested in decarbonization of the world. So these are kind of conflicting needs or growth areas. However, there are technologies that are being developed that can reduce energy consumption of AI. And actually, my company is one of them doing that, trying to play a role in that space. So I don't believe, we can reduce the demand, but we can affect the rate of demand. Because every time the hardware people come up with more capable hardware, the software people makes their problem larger, right? So then the hardware is not sufficient to solve this larger problem. Then the hardware guys go and bring a better hardware, and the software guy says, let's consume that, make our problem bigger. So this thing keeps going on. I mean, that's what drives the growth and advancement of technology. So that will continue. But some of these technologies that is emerging, they can affect the rate of increase. So that's where we are trying to focus on.
I will put Beddhu's company's website if you're interested in connecting with him or learning more about his business and what they can do to help. Thank you, Beddhu, for joining the podcast.
Thank you.
Thank you for listening. I want to let you know that we will have an episode at the end of the series called Putting It All Together. We will discuss how blockchain is the foundation and how it weaves a thread intersecting all the major components of Web3. So look for that episode. Also, I am uploading an infographic online, so look for that as well to outline the different components in the pieces. And we'll talk about how all those come together again at our Putting It All Together episode. All right, so today's token clue is smart contracts. So go to Curryville Tech Talk and click on Tech Ticket to get your token. I am Krystal Curry. Take care.